When the temperature outside climbs and the season shifts to spring, sitting at a desk suddenly feels restrictive. There is a very real friction between the energy of the warming weather and the static environment of a traditional passive indoor classroom. Reading about photosynthesis or animal behavior on a flat textbook page simply cannot compete with the physical world waking up. The sensory input of smelling wet earth and feeling the warmer air draws young students' attention squarely out the window. This is where experiential learning becomes critical. It's the practice of educating through direct, hands-on participation, rather than asking students to passively absorb a lecture. There is a massive gap between memorizing a list of an ecosystem's components and actually kneeling in the dirt, turning over a rock, and seeing an invertebrate habitat functioning in real time. To truly engage young minds with scientific concepts, we have to push past the four walls of the classroom and let them actively participate in the environment around them. Look at how the sunlight changes here. As the sun rises higher and casts sharper shadows, it establishes the environment as a dynamic, living curriculum. The longer days and increased biological activity create a strictly timed window. It is the ideal environment for immersive, cross-curricular activities that blend science with observation and communication. Nature automatically provides the structure for scientific discovery. Educators simply need the right methods to harness that momentum before the season turns. Early spring is the optimal time to observe how life restarts. It's when biological life cycles are most visible and local ecosystems begin their annual renewal. This flowchart illustrates a continuous biological life cycle. Shifting our focus downward to the soil layer, mapping the unseen flow of nutrients, introduces inquiry-based learning. Outdoor experiments, like testing soil pH, force students to ask how ecosystems work before getting the answers. Activities like gardening and nature walks build a concrete understanding of local ecosystems. Students need this foundational awareness to grasp larger, more complex concepts like global sustainability. Tracking this quiet, foundational growth in the spring provides crucial context. Once students understand the habitat, they are ready to understand the complex animal interactions that dominate the summer. As the academic year moves into summer, peak biological activity allows for much more complex, tactile interactions with living animals. Take vertebrate classification, the system of sorting animals by their backbones and physical traits. It's an abstract concept on paper, but it is instantly demystified when a student meets a live animal face to face. When safely handling a crested gecko or a lesser tenrec, adaptation theories suddenly make sense. They can feel the gripping scales or the fur keeping them alive. This node-based diagram shows a food web, tracking energy transfer from primary consumers up to apex predators. We explain these mechanics through specific workshop animal diets, connecting a leaf-eating giant snail at the bottom to a royal python near the top. The moment a student looks a tree frog or tarantula in the eye, passive reading stops. They start asking rapid-fire questions about what it eats, how it moves, and where it sleeps. Physically handling an animal takes abstract biological theory and turns it into undeniable physical evidence in the palm of their hands. But the living calendar extends past biology. Summer is the ideal time to take physics and chemistry outdoors through interactive science workshops. Watch this viscous, brightly colored liquid bubbling and stretching. Hands-on chemical reaction exercises, like slime making, physically demonstrate material properties and transformation in real time. During material testing exercises, students are challenged to predict how different substances will interact. They then immediately verify their hypotheses through practical, messy application. When an experiment yields a surprising visual result, like a sudden change in texture, it creates a powerful psychological anchor. This immediate visual evidence ensures the scientific principle is remembered long after the lesson ends. By linking these tactile experiments directly to strict STEM curriculum goals, educators build an educational foundation that outlasts the summer break. Beyond the science, there is an immediate psychological shift when a hesitant student moves from pure observation to safely holding an unfamiliar animal for the first time. Stepping up to hold a royal python or a giant insect requires overcoming a very natural barrier of fear. Doing so builds real emotional resilience and visible confidence among their peers. This creates an empathetic connection. It is the unwritten byproduct of bringing students face to face with the fragile participants of an ecosystem. In fact, educators consistently report that these hands-on workshops spark intense engagement from children who might otherwise struggle with traditional reading and writing tasks. These encounters foster a profound, lasting respect for living organisms, grounding scientific literacy in genuine empathy for the natural world. The warmer months offer an incredible outdoor laboratory, but the window is short. The peak opportunity for this kind of environmental learning passes quickly. To capitalize on the season, you can book a mobile wild science workshop directly to your school or holiday club, bringing expert handlers and animals right to your students. With over 20 different topics available, these programs offer complete logistical flexibility, ensuring each session is tailored precisely to your specific age group and curriculum needs. Do not let the season pass by passively. Transform your science lessons into unforgettable living adventures today.